Lesson 41 is going to steal a bunch of the concepts from lesson 40. 41, again, you'll want to refer to this table here. You'll have to do the line of symmetry, your vertex, your max and min. What's new in this lesson is going to be finding your x-intercepts, which is going to spill over from Unit 7, and the y-intercept, which really you've done throughout the entire year. To find your x-intercepts when you have a quadratic function in standard form, what you're going to do is you're going to go ahead and factor this trinomial down into two binomials. Like plus plus is plus plus, plus minus, minus plus is minus minus, so on and so forth, where you take that trinomial and factor it down to two binomials. And then you'll use the zero product property to come up with two x-intercepts. The y-intercept is simply found by putting 0 in for x and solving for y. So the first example we have is carrying over from yesterday. Again, write the equation for the line of symmetry here. The line of symmetry, you have x equals negative b over 2a. So you'd substitute in for b and a, much like you did yesterday. You do your computation, we wind up with negative 8 over 2. And again, line of symmetry is written as an equation, so we wind up with x equals negative 4. We use this x value and we plug it in down here in for x to figure out our y value for our vertex. So we plug in negative 4. When we plug in negative 4, we do our computation here. And we go ahead and simplify our problem, and we find out f of x, or y, is negative 4. Again, vertex is a plot, so we'd write it as a coordinate, negative 4, negative 4. Then we'd go ahead and state if the graph has a maximum or a minimum. Looking at the equation here, our a value is positive, so the graph would curve up. Therefore, this graph would have a minimum. Today's new concept. Factor the equation and find the x-intercepts. So I take the trinomial x squared plus 8x plus 12. The binomial, or the trinomial is plus plus, therefore my binomials would be plus plus. So now I think, what times what would give me 12 that when added together would give me 8? 6 and 2 when multiplied together would give me 12, and when I add them together would give me 8. So after you factor this down, the next thing you would do is take these two binomials that you have and set them equal to 0. That's called our zero product property. So we would say x plus 6 equals 0, taking this first binomial, and x plus 2 equals 0. And then you simply solve for x. Getting x alone on the first one, I'd subtract 6 from both sides. Getting x alone on the second one, I'd subtract 2 from both sides, solving equations. And I find out that my x-intercepts would be negative 6 and negative 2. Now to find my y-intercept, as mentioned from the table, is you simply put in 0 for x. So we need to get rid of x to solve for y. So when I put in 0 into that equation, and I do my computation, 0 squared is 0 plus 8 times 0, which is 0 plus 12, we find out that f of x, or y, is equal to 12. So my y-intercept is 12. From the information that we've gathered, we're now able to graph the function. So we're going to go ahead and graph this given the information that we have. So the first thing, I'm going to go ahead and do the line of symmetry and graph x equals negative 4. One thing I do want to note here is that my y-intercept is 12. Notice on my y-axis here, there's no way I can get up to 12. So what I need to do is go up by different intervals other than 1, and I'm going to go up by 2's. So I need to state that on my graph. So I've indicated now that my intervals are going up by 2 rather than 1. I'm going to go ahead and graph the line of symmetry. And that is x equals negative 4. I've graphed the line of symmetry. The next thing I'd want to do is plot my vertex, negative 4, negative 4. So my vertex being negative 4, negative 4, I'll go over 4, down 4. There's my vertex. The next thing is obviously this has a minimum, so this graph is going to go ahead and curve up because my A value is positive. So the next thing that I want to go ahead and plot is my x-intercepts. So I would have -6 and I would have -2 would be my x-intercepts. And lastly, I'm going to go ahead and plot my y-intercept, which is 12. So my y-intercept 2, 4, 6, 8, 10, and 12 being up here. Now you can kind of see that curve. Again, when you draw this here, I don't want it to come to a point because it's a U-shaped graph. So make sure that the bottom of the graph has a nice smooth curve. So your sketch should look something similar to that, going through your intercepts, x and y, as well as your vertex. Question 5 is the same process. I'd like to have you go ahead and pause the video for at least A, B, and C, which we did yesterday. Work through A, B, and C, and we'll pick up where we left off there. So why don't you go ahead and work through A, check back in, and then B, check back in, and C, and check back in. Alright, for our line of symmetry here, again, using that equation x equals -b over 2a, I substitute in, do my computation, I wind up with 8 over 4, and my line of symmetry would be x equals 2. To find my vertex, I'm going to throw 2 in for x, do my computation, and I calculate, and finally simplify or combine my like terms. I find out y is -2. Vertex is a coordinate or point, so I'm going to list it as an ordered pair. Next thing I need to determine in C is, does it have a max or min? Well, this graph curves up because 2 is positive. If it's curving up, it's going to have a minimum. And what's new today is we need to go ahead and do part D. Now, D is slightly different from the previous problem in 4. In 4, x value was 1. Now, when your A value was 1. Now, your A value here is 2. When A is greater than 1, or when A is not 1, remember what we do. We take the product of A times C. So I take 2 times 6. There's that AC value. 2 times 6 is going to be 12. Then, what we did in the previous chapter is we rewrote things. So I had 2x squared. I take this leading term. I see minus plus. Well, that's going to give me a minus minus. So minus some number, and then we have plus 6 at the end. So I need to think about what times what. So 2 times 6 gives me 12. So what times what? When I add that together, I would get a -8. That when multiplied together, they give me 12. And again, that would be 6 and 2. So I'd say 6x in one box and 2x in one box, and it really wouldn't matter which way I put it because they both are negative. So -6, -2, giving me that -8. From here, we factored by grouping. So we grouped the first set, we grouped the second set. This is the critical step right here. Change this to a plus and make this a negative, and then we go ahead and group them. So once we factor by grouping, we think to ourselves, all right, what can we factor out? What is the GCF of this first term that we can factor out? And in this problem, we can factor out a 2x. When I factor out 2x, I'm left with x minus 3. Our whole goal is to get this to be x minus 3. They need to be identical. So I factor out a -2. When I factor out -2, I wind up with that x minus 3. And another way to check is go ahead and distribute this -2 back in. -2x and a +6 is what we had in that previous problem. Now we write that into two binomials. So we will have 2x minus 2 when we combine this and that, and then our x minus 3. Now that you have factored, when A is not 1, you would go ahead to figure out your intercepts is take these two binomials and do your zero product property. So you're going to set them both equal to 0. Your x minus 3 set it equal to 0, and your 2x minus 2 set it equal to 0. In both of these problems, you would go ahead and solve for x. So solving equations, solving for x. Carrying through that process, I'd add 3 to both sides. When I did that, I would find out that x equals 3. Here I'd add 2 because it's minusing, and then I divide by 2. 2 divided by 2 giving me 1. So my intercepts for x would be 1 and 3. Down in E, to find the y-intercept, again, to find y-intercept, we need to get rid of my x values, so we put in 0 for x. Do your computation, y equals 6. So your y-intercept is 6. Next, we'd use this information to graph the equation. So here's my info here. I look at my values, 2, 2, negative 2, 1, 3, 6. It looks like on this graph I would be able to hit anything, unlike the last problem where I had an intercept of 12. So I'm going to go ahead and leave these as intervals of 1. Graph part A, the line of symmetry. Next I would go ahead and plot the vertex. That vertex being 2, negative 2. So over 2, down 2, plot. This graph has a minimum, so it's going to curve up. Again, we know that because my A term is positive. Next, I'm going to go ahead and plot my x-intercept, which is 1 and 3. And last, my y-intercept of 6. So 2, 3, 4, 5, and 6. Now I have all that information. I can see that smooth curve or that parabolic function, and I can draw or sketch that smooth curve. So my sketch should look something similar to that. This will conclude lesson 41.